Welcome to the Mindfulness Podcast. This is Dr. David Black. My guest today is Dr. Steve Cole, professor of medicine in the Division of Hematology-Oncology at the University of California, Los Angeles School of Medicine. His research examines the association between social factors and the activity of the human genomes. He has pioneered the use of functional genomics approaches in the social and behavioral sciences, including tests of stress reduction and mindfulness-based interventions on genomic activity. He is a fellow of the American Association for the Advancement of Science, and I've been lucky enough to collaborate with Dr. Cole and gain some of his mentorship over the last decade plus. Welcome, Dr. Cole. You have made it's great to have you. You've made major contributions to the field of social genomics. I always read your work, and I'm so impressed about the language, about the introduction of this very technical understanding to what humans are and what we potentially can do to help their health. So just learning from you, a very experienced person in this field, what is the field of social genomics, put simply, and what are we trying to accomplish with that?
Well, it's actually easier to answer number two as a way of doing number one there. So basically what we're trying to do is promote human health and well-being, just in the broadest sense. And the primary way that I think the biomedical establishment approaches health and well-being is sort of upside down, which is really the study of illness and disease and sort of the collapse of health and well-being. And so for now centuries, medicine and later sort of this organized biomedical research science has sought to understand what goes wrong in disease, and to some extent sort of how healthy physiology operates, but especially what goes wrong when you get a case of cancer or a COVID infection or a case of Alzheimer's, that kind of stuff. So as the years have gone on, we've sort of refined the precision of the kind of, if you will, kind of technical or scientific analysis we can do of those kinds of questions, starting with like, well, if you've got cancer, it's because you got a big lump in your lung here, right? Who knows where that lump came from, down to like, okay, now we know that it's composed of cells of your own body and they're misbehaving, to today's world where we really look inside cells and we ask, why do cells behave the way they do? And in no small part, that's because they're programmed by the human genome, by our DNA. That's the blueprint that makes cells. That's the blueprint that, when damaged, creates, out of control cancer cells. But that's also the blueprint that records millions of years of evolutionary wisdom about how cells and bodies should respond to the world around us if they want to survive and thrive. So in addition to this story about, just sort of the mechanics of putting a body together, there is a huge amount of acquired wisdom stored. It's almost like a biblical text recording our ancestors' experiences and the various ways we could respond, and leaving us with essentially memos for today about, sort of, if this happens, try that. And this is all happening automatically, kind of physiologically, kind of at the operating system level of the body. We don't have to think to turn on this gene or turn off that gene. But one of the things we know is that life has been wonderful and terrible at various times within everybody's life, and has been for all of history. So the genome, as part of this acquired wisdom, has encoded or learned a bunch of programs for how to be in different aspects of life. So we've got one program that runs most of the time, that sort of grows our bodies in a healthy way and leaves us sort of generative and creative and sort of like at peace, and many of the psychological states that you guys are familiar with in terms of your studies of mindfulness are ideally, at least in our world, the default state of a human being. But there's also these other times when, like, hey, bad stuff happens, and now is not the time to meditate because the tiger is coming and you got to run, or there's like this crisis afoot and you got to deal with it. So there's a whole other set of programs that are basically waiting, encoded in the human genome, to activate when we run into trouble like that. And so what social genomics really is an effort to understand how the world around us changes the way our genome works. What kinds of programs are embedded in our DNA that activate when we feel threatened or insecure? And how can we, deploy those programs when they need to be deployed, when it's what we call adaptive, when it helps us survive some kind of a challenge. But also, how can we leave those programs behind when it's time to go back to this more relaxed, generative, creative mode of life, this more socially relaxed and sort of, you can think of it as the good life, if you will. So it's really this effort to kind of take the best of the human genome's programs and make sure that they're running in our lives, and that they're not chronically lives that are, let's say, shorter than they could have been because we're running a defensive program all of our life. We feel threatened or insecure. We feel, the world around us is untrustworthy, or people hate us, or there's always a risk that we're going to fall out of grace. So it's really an effort to understand social world around us, how that becomes differences in health within us by kind of inspecting this programming that we've inherited at the level of the human genome.
And can you talk about the characters that were involved in this story? We have the DNA character, the RNA character, the RNA translated proteins, and cell types. So maybe we'll just play quickly. I don't want to do a genetics 101 class, but
no,
that's just because I have to remember this every time too.
Right. Let's get the players straight here. Yeah. So, bodies, the things we see, as you know, are made up of cells. Cells are, not identical in what they do. I have an eyeball cell that helps me see. I've got a brain cell that helps me think. I've got, immune cells that help me fight off invaders or repair damaged tissue. So cells have kind of these different properties, but they're all part of me. So the part of the definition of me is that this cell was created from my personal blueprint from the, the realm of the human genome. So it's really DNA that defines who I am, in distinction from, let's say, other collections of tissue that happen to be people, or that happen to be starfish or whales or stuff like that. So DNA is, you can think of it as like this molecule that encodes instructions for how to make a body, and also how to, if you will, make these different types of cells that occur within a body. But the DNA in every cell is the same. So there's not enough information in there to make an eye cell or a brain cell or an immune cell. We need additional information to say, let's treat the DNA genome as sort of a menu of opportunities for making pieces of a cell, for creating a body. But let me order different meals from that menu if I need an immune cell versus a nerve cell, or sort of like a liver cell or something like that. So the DNA is the same in all of these cells, but the subset of RNA molecules that get built off of that DNA, that's what differs. That's what makes individual cells different. And it's also what allows cells to respond to things. So let's say, my immune cells are walking around, taking it easy, and suddenly they bump into some wounded tissue. And that, boy, they need to do something about that. They need to, search for bacteria and kill them if they're there. They need to sort of clean up the debris and start reconstructing some replacement healthy tissue. So that's a challenge that this cell has to respond to. And the way cells respond to challenges is also by, if you will, turning on or turning off different subsets of genes in some kind of complex recipe that's, again, shaped by evolution. So the turning on and turning off basically involves DNA that is, sort of a template for making a protein, which is actually the molecule that's going to do something in a cell. That's going to be a piece of a cell skeleton, or a receptor that allows the cell to, sort of perceive the world around it or respond to it somehow. So it's the protein that's actually going to get stuff done. It's the genome that contains the instructions for making all of the proteins that a body possibly could make. And it's the RNA that is the version, the subset of the genes that are actually being actively, what we call, expressed at a given point in time. In other words, we've got these stretches of DNA, 20,000 or so of them. Usually in any given cell, only about 5 to 10,000 of those are really materially active in any given cell type at any given point in time. So there's got to be some kind of decision making about which genes to turn on and turn off. And the way these genes get turned on is they get copied out of DNA form into an RNA form that then becomes a template for making the proteins that do the work in our body. So you can think of the RNA world as sort of the order that you place at the menu of the human genome in order to get the meal that you need to be a healthy, thriving human being.
Very good. And there's an introduction to a textbook right there. That's good for me, and that's very informative. Thank you so much. And so there's the baseline of the characters, and then you bridge it all together. And I think you pull from various fields in your writing on this. The Conserve transcriptional response to adversity. I enjoy this because it talks about the longevity of humans, our ancestry, plus that system, all those features of the system you just indicated, and then why it might be useful to understand. Do you want to briefly talk about that piece now, the CTRA, as you call it?
Yeah. So, the CTRA really is a pattern that we bumped into that it's like a theme that kept recurring over and over again as we started to use these amazing techniques of molecular biology. Once upon a time, we could only really measure one gene at a time, but somewhere back in the kind of the 2000s to 2010 period, we started to really be able to measure the activity of all 20,000 genes in the genome by screening, for the amount of RNA present in a collection of cells that came from each of those 20,000 genes. So we started to be able to measure what I kind of conceptualize as all the Legos in the box. Like no longer, do I get a couple Legos and have to wonder how they fit into the castle that I'm building. Now we've got, we know that these are all the genes that are present in the DNA. There's no other, sort of dark matter present at that level. So now our challenge is we've got all the pieces. We should be able to figure out how to put a human together and how to put a healthy human together when the healthy human is maybe, sort of not so healthy, how to encourage the whole system to move in a, sort of a healthier and more generative direction. So we had this toolkit of genomics looking at all 20,000 messenger RNAs, we call them, that are coming off of our 20,000 DNA genes. And we started, to look at this really in the world of virology. It was actually the HIV epidemic that really kicked off the work that we did, where we were trying to understand a much simpler genome. HIV is, sort of like very, very small number of genes, but that's about all it is. It didn't have, muscles or eyeballs. All it really was a package of genomic instructions that would then get introduced into a human cell and cause that cell to make more copies of the HIV virus, and also kind of rob that cell of its ability to carry out, good, effective immune responses. So that's why people got sick in the context of HIV infection. So we were originally doing genomics, studying RNA and DNA and that kind of stuff to try and understand this very simple genome that was obviously relevant to the health of people who were infected by this virus. But the principles that we started learning were generic. In other words, if you understand what turns on and turns off a viral gene, you could take those principles and then go over to the human genome, and you could start asking, do the same things operate over here? And the genomes are a little bit different. So, what is the human genome's program for responding to this, that, and the other thing? So in HIV, we were looking at things that were surprisingly powerful risk factors for, sort of early immune decline and death. Things like living in the closet. That was really bad for a gay man with HIV infection. That would chop their lifespan by about a third. So it was worth understanding why that state of being, that way of living, sort of like pretending to be straight, to be, quote, normal, and therefore always at risk of discovery and always kind of having to inhibit some of the most rewarding and important aspects of your life. Like you can't just go into work and say, hey, I had a great weekend with my partner. They'd be like, your partner? Was that your wife? So it'd just be like this constant sense of low grade threat. People weren't after you with bats most of the time, but you were always kind of acutely worried that, if you just said the wrong thing or someone saw you someplace or something, you were constantly worried that you were going to be discovered and essentially fall from grace, lose your job, your friends, your family possibly. So it was kind of a high stakes lifestyle gamble to do that kind of thing. So the more you understood about, the experience of closeted gay men, and then HIV comes along and raises the stakes ever more, the more, you're not surprised that, given that level of stress, that it would do something to the body. But, once we're in the realm of HIV virology, we want to know what exactly it's doing to the body, because, we don't want them to get sick. We don't want them to die any faster than, any of us do. So the more we can understand about what's gone wrong with this sort of social risk factor of closeting, leading to a virus eating up a body faster, that was our big initial challenge. So we'd worked out some general principles there. And then this was like in the early, sort of 2000s, when the human genome draft came along. And then we had, progressively better drafts, and we started being able to measure these 20,000 genes instead of, just 20 or so. We started trying to ask about other kinds of diseases that didn't involve pathogens like HIV, that involved our own genome somehow running amok, things like cancer or neurodegenerative diseases, or sort of heart disease, atherosclerosis, that kind of thing. So at the time that we were getting these great molecular biology tools, and starting to point them at humans, one of the things that was becoming more and more apparent, and is now really overwhelmingly apparent, but the kinds of risk factors that we'd been studying for years, things like stress and anxiety, they sound bad, but when you quantified these things in epidemiology, it was actually surprisingly not so much those kinds of psychological states as social states that were the big risk factors. So we, were talking about our HIV work and bumped into one of the guys that had really sort of spotted this supremely important role of social life in human physiological health, John Cacioppo, who was sort of a legend in psychology for really putting loneliness on the map, and not just in psychology, but in society as a whole. And John came up to me after one of these think tank presentations and said, can you do that genomics trick on the human genome for things other than viruses? And John was so smart that I just totally lied and said, yes, I can do that. I'm happy to help you do that. No problem. I had no idea exactly how to do that, but heck, if anyone could do it, it was going to be, John and us trying to put it all together. So that led us to take this very kind of toe in the water, incredibly small first step, where we just got blood cell samples from, a really small number of individuals who are chronically lonely, that had been part of a big study John had been doing of a couple hundred people for, at that point, about 10 years. And then, another set of blood samples from a small number of people who were really not lonely, or highly kind of, if you will, socially integrated or enmeshed in communities. And we just thought, let's just take these RNA profiling tools, these things called microarrays at the time, and just see, what might be different. And we've been doing this a fair amount with, test tube studies. This was really our first effort to take this into the wild of free range human biology. Up until this point, we'd been doing these with like, hey, let me take some, 3 samples of cells over here and 3 samples of cells with some chemical over here. That was the kind of stuff we were doing at the time. But we thought, it's the same RNA. We should be able to do this with, living, breathing humans leading life. So this was our first attempt to look at a dimension of life, like loneliness and social isolation versus social integration, and ask, does the genome notice anything? Or are these immune cells just doing what, in general, the kind of the sort of physiology dogma would suggest, which is like they're totally ignoring your social world and just running around looking for microbes. They don't care what kind of a body they're living in. They're just looking for bad guys and trying to kill them. So, we got the data in, and it was really a surprise. I have to say, we'd been doing these cell studies, and it was often hard to, figure out what is the biological theme here. We could measure, some genes that were more active and some genes that were less active, but often it was kind of a hodgepodge of genes, and there wasn't really a very clear theme or signal. It was hard to understand what it all meant when we got these lists of genes that were more active in some cells than in another. But for the lonely people, man, that was a jaw dropper. So when we looked at the lonely people, what we saw is Well, first, a bunch of genes that are involved in inflammation were more active in the white blood cells, the immune cells of these individuals. And that was, sort of a pretty useful piece of information, because this was all happening at about the time when we were starting to appreciate that inflammation, while important in protecting us against injury when deployed in kind of sparing short-term fashion, if inflammation is active over the long run, it accidentally serves as a kind of fertilizer for the production of most of the diseases that are the major sources of death in the world we now live in. Things like heart attacks, neurodegenerative diseases, metastatic cancers, that kind of stuff. So seeing more inflammatory gene expression in the white blood cells of the lonely people really matched up with the epidemiology pretty well. Those were exactly the kinds of diseases lonely people tended to die of at higher rates. The other thing that we saw, which was immediately recognizable from our days in HIV, is that the lonely people, it's not like all of their immune genes were more activated, only this inflammation-related block. There was another block that was noticeably suppressed in activity, and that involved genes that play a role in defending us against viral infections, so-called type 1 interferon genes. And we know about those genes from HIV because it was, in fact, the failure to activate these type 1 interferons that was the sort of the gateway for HIV to run amok in these gay men who were living in the closet. So it turns out that the physiology that was going on with them was this stress biology, this fight or flight stress biology, norepinephrine, the neurotransmitter released by these fight or flight nerves. This was all stomping down the gene expression, the RNA production that would otherwise be taking place for these type 1 interferons. And that allowed, when an HIV virus infected a cell, that basically meant that cell could be easily converted into a virus factory in a way that wouldn't have happened if this type 1 interferon system had been able to kind of turn on and intercept the virus before it could start making copies of itself. So we knew that story already held in the context of HIV. What we then discovered is in the context of loneliness, that in general, this was happening all the time, even in bodies that didn't have active viral infections. So this kind of teeter-totter regulation, and just like this socially isolated, lonely, often mistrusting, disappointed, wounded individual was basically running a body that was going to, make more of this fertilizer for chronic diseases at the same time as it's making less of this kind of defensive capacity for viral infections. So for a long time, this stuff, kind of really blew up when we published it. People were excited. And so we started getting lots more people coming to us and saying, hey, that thing that you did with loneliness, can you do that for chronic stress or poverty or, any one of a number of other, what we knew from the epidemiology were risk factors for disease. So we started doing more of these studies. And what we discovered is that profile that I just talked about of greater inflammation and less antiviral biology wasn't distinct to loneliness. In fact, we saw much the same thing in people who were, sort of caregivers for somebody who was dying of cancer, really stressed people. We saw the same thing in people living in poverty. We saw the same thing in people with PTSD. We saw the same general pattern across a wide range of different things that didn't really have a lot in common in terms of the type of people who were involved or in terms of the specifics of the social or psychological world that a person was inhabiting. All that seemed to be necessary is that people feel a sense of threat or uncertainty for more than a short period of time. If the body is feeling threatened or insecure, you don't have to ask for this, you don't have to think about it. There's this program wired into the kind of the what we call the regulatory architecture of the human genome, the rules that turn, the wiring diagram, if you will, of turning on and turning off genes in a human being. This program says if you're feeling threatened and insecure, start making more inflammatory gene expression in white blood cells and stop making type 1 interferons. And we learned later why that was. This was actually, in the way we used to live, probably an adaptive thing to do. But in the world that we live in now, it doesn't serve us well. It brews up chronic disease, when life is hard and leaves us vulnerable to viral infections, and makes a surprising degree of connection between the world around us and the way we're connected to it and the world inside us and how it operates.
And can you add that what a beautiful historical perspective, and also showing like an evolution of scientific thinking itself. That's why the stories can be so fun. You're looking at one thing and see this other thing is also at play. The importance that you were just making, I just want to attend to it, because it is really important to note that we do have a system that is protecting us. And that you did mention that briefly, but can you just connect it to that balance schematic that you're talking about? Like you found these two dynamics, and there tends to be like this balancing act that's happening. And in the acute setting, it is very important to have a system that has evolved to do this. Can you just tell us again why that system is so good when there is an acute stress?
Why would you build a genome that would do this, right? I mean,
Yeah.
doesn't it seem like a bad idea to mess up your immunology whenever you have a bad day or a bad week or something like that? So one of the things we know from, biology theory in general, kind of, evolution, natural selection, that kind of stuff, is everything that's there at least isn't a bad idea and probably makes sense for some reason. You may not be aware of it, but it's been shaped by millions of years of trial and error. So in this particular case, as far as we can tell, the reason this program is still in our genome is related to the forecasting capacity that stress and threat and uncertainty has for microbes. Now, in the world we live in right now, that forecasting capacity, is poor at best. But it took us a while to realize that in the world that we used to live in as human beings, in fact, the forecasting was pretty good. So this requires a little bit of anthropology. It turns out, so remember I talked at the beginning about these two different modes of existence, this sort of relaxed, healthy, sociable, easygoing, creative, curious, sort of empathic mode of existence that, sometimes the wonky physiologists call vegetative existence. This is where you're thriving and growing and doing all that good stuff. And then there's this other mode of kind of like fight or flight stress physiology. So most of us these days feel like we're in some degree of, at least mild fight or flight stress physiology, if not most of the time, at least much of the time. So, and one of the things we knew is that a lot of the risk factors, things like loneliness or poverty or PTSD, tend to activate this sense of insecurity or threat or uncertainty. So we kind of, originally were theorizing about this through the lens of our personal experience. And it really wasn't until we put our anthropologist cap on that it started to make sense. And once we did that, we realized, the way we live now is not the way we've always lived as human beings. In fact, the vast majority of our species history, we weren't stressed out all the time. For the vast majority of our time as hunter-gatherers or kind of early stage agrarians, people, like farmers and that kind of thing. Actually, it turns out we just were not incredibly stressed most of the time. Hunter-gatherers, there's a decent number of them still around. And when anthropologists study them, they're like, man, these people are chill. They're pretty happy. They spend about a third of their time hunting and gathering, mostly with pals. They spend about a third of their time sleeping, and they spend about a third of their time hanging out around the fire gossiping. That is a pretty good lifestyle. They're not like in abject terror all the time. They're not running around constantly trying to stay on top of their email and deal with various, sort of like crazy political problems. They're not running around all the time trying to get their paper published or their grant funded or anything like that. They do have stresses. They tend to be short. And the way they deal with them is by collaborating with other members of their little hunter-gatherer tribe or their farmer community. So they may need to raise a barn. That's hard work. But if you get 100 of your neighbors to help you put the barn up, that's like a day. So it's like a day of stress. Human body handles that well. A week of stress, man, that starts to get a little dicey. A lifestyle of stress, the way we lead it, you don't need the stress to be intense. What it turns out is it's the chronicity, the extent of the stress over time that really leads to this wholesale remodeling of bodies into this kind of chronic stress conditioned mode. And that's where we lead our lives these days, is in a constant sense of vague threat and uncertainty, this kind of constant low grade drizzle of, sort of concern and worry and anxiety. And that often turns into social reflections in terms of mistrust of other individuals and hostility to our group members and all kinds of pathological consequences of leading life constantly in this threat mode. But that wasn't the way we spent most of our time. So back to the hunter-gatherers, the only time they really had a lot of this norepinephrine flowing through their bodies, this fight or flight stress neurotransmitter, was when the saber-toothed tiger runs through the camp, or the neighboring village tries to raid you, or something else like that. They really were not threatened on a chronic, constant basis. But when they were threatened, they were likely to get hurt. All of the things that threatened hunters and gatherers were stuff that would like bite you and scrape you and bleed you and all this other kind of stuff. So it wasn't actually a bad idea if you were running an immune system. It turns out immune systems have, broadly speaking, two different kinds of responses. One kind of response that's good against intracellular pathogens like viruses, and another kind of immune response that's good against extracellular pathogens, things that live outside cells, but maybe in our tissues, like bacteria. So when we get wounded, when the saber-toothed tiger bites us, or we get speared by the neighboring villagers or something like that, that usually involves sort of opened flesh and invasion of bacteria and so this need to wound heal and fight extracellular pathogens. So we need a certain kind of immune response to that. And what it turns out the immune system was able to do is, over many hundreds of thousands of years of evolution, it learned that it could predict that you would need an antibacterial response and a wound healing response when it heard norepinephrine. It's like, if you're this scared, you're probably going to get hurt. Let me get all of the kit bags together for dealing with a wounding injury now. I'm not even going to wait until you get wounded. I'm going to get ready for this damage ahead of time in this kind of predictive way, which we know actually, it turns out all of human physiology is built with all of these prediction rules built into it. So the immune system basically developed this listen to stress biology, predict the pathogen, and pivot this kind of, again, this wiring diagram, or this logic about how to behave. Now, when it pivots towards this antibacterial response, this wound healing response, and this sort of control of wounding infection, it's got to pay a price. It turns out it can't do all the different kinds of immune responses equally well at the same time. So the way it pays that price is says, hey, lighten up on the antiviral response for right now. Because you know what? You're not sitting around the fire or mating with your, friends or anything like that right now. Those are the ways you're going to get viral infections. We don't get viral infections from the saber-toothed tiger because the virus that infects the saber-toothed tiger generally can't replicate in human tissue. But bacteria that get introduced into your wound, either from the saber-toothed tiger's tooth, can infect a human. And so can, let's say, the contents of your intestines, which might have been opened up when the spear hit you or something like that. So this pivot is really sort of saying, let me sacrifice this long-term campaign that I have to fight against flus and colds and coronaviruses and all this other kind of stuff for now. I can get back to that later. And that, I'm going to need that for when I'm hanging out, exchanging saliva on all the food that we're sharing and all this other kind of stuff. But for now, that is not a serious problem. I got to not bleed to death in the next half hour. I got to stop this bacterial infection before I get sepsis and die. So the immune system is basically saying, drop that for now, pivot over here, do that. And I'm betting that sooner or later, the crisis will go away. I'll deal with the bacterial infection, and then I can get back to fighting the viruses later. So that's the way we're built to live, is like basically tranquil social environments where antiviral responses are a great idea, with these periodic extreme acute pivots into this kind of wound defense bacterial response mode of existence. The problem is the way we live now, we've evolved a culture where we never feel so tranquil that the immune system gets back to this highly polarized antiviral state. It basically hangs out in this inflammation promoting state a little bit more than it should for mostly all of our lives. And that is a new way of being for the immune system. And as a result, the more we have this kind of experience of threat, the more that fight or flight stress physiology keeps that inflammatory biology going, promotes disease, and at the same time leaves us vulnerable to viruses.
What a sophisticated description. Thank you. And what's coming to mind, it's an imperfect example, but my son was hit in the face by a plastic baseball bat at a recent Easter party this past weekend. And, you see the blood, you see the scabbing, and it's that part of the system you're talking about, like this immediate response. It makes a lot of sense. And I'm so thankful we have that type of response. Yeah. So my son can heal up and do fine. Right. The bruising can go away and the cells can come in and remove the debris. And then I think of the times he goes to school and gets like a rhinovirus. And I'm so thankful for that it's not totally attending to the cut on his eye. It shifts, and that balance will go to, okay, we need to get intracellular here, kill whatever virus this is, and clear that debris. So, I mean, the beauty of all of this orchestrating is fantastic. And that's why I love your work, because if you read between the lines, you can see all this beauty historically, the ancestral notes, and the utility, and then kind of this fear. I try not to get it fear inspired, because perhaps there are still ways that humans can cope to uncover with their novelty and innovation and learning ways to account for these things. And maybe that's where we will go next, but in a model where humans will have to face this. So this is just something we have now. This is a modern environment. And people are pretty familiar with the modern environment, so we don't need to go into that. We know the pressure. We know the never-ending opportunity to be engaged in the social world and in an anxiety-provoking context. Just turn on your phone, and in any moment, there is a war, there is a person mad at you, or something you have said now or in the
Twitter,
past.
Right? I mean, it's just like that one's like the worst psychological parasite on human will.
So it could never. There's a potential of this actually never ending from here on out for a person's entirety of their life. Okay, so that's so fun. Thank you for giving me the intro there. You've connected it to the social stress element. I think a lot of the models and teams you've worked with, it's kind of figuring out in one way or another a sample that is either isolated or under severe stress with, say, caregiving or work-related stress. So these are different ways to approach a similar model where, and it's one that you've been pointing to. So especially among individuals with chronic stress, that balance of the system is going to really head towards the disease-oriented side, where it's not healthy to always be in that chronic state. Okay, so what about interventions? Here's the golden ticket to try to perhaps uncover what we could do as agents in our environment. You and I have talked about, and thank you for joining me on that paper in Current Opinion on Psychology. We started to borrow your model and say, okay, what level would something like a stress reduction program, like a mindfulness training, given its use as a learning technology that humans can learn, they can both in some ways understand their mind, or at least understand the environmental events that could produce a toxic feeling of stress and then the downstream effects that you've talked about. Do you believe something like a mindfulness training program, from what you've seen on the studies so far, we together reviewed some randomized controlled trials, that you can intervene on this biological process in the field of social genomics?
Yeah, the short answer is yes, absolutely, you can intervene. And I think the question becomes, sort of in any given person's life with the things that they confront, what is the best way to intervene, or what are the options that you have? So, let's kind of march down this, if you will, kind of causal ladder, just starting at the level of the world that we live in. One way to intervene in all of this is to make effective change in the world so that people are not feeling so threatened and insecure and socially precarious, or economically precarious, designing a better way of leading our lives, one that's more consonant with the what we know to be the general health of the human being, expressing itself best in situations where people feel generally appreciated and secure and part of communities. So revising social life, evolving different ways of being, either as a society or through voting with our own individual feet. There's been a huge amount of that in the last few years as people have, in very, sort of intentional ways, consciously decided, I want to live a different life, everywhere from occupationally and the, sort of the infamous Great Resignation to, people changing where they live to, be around people who see the world they do and appreciate the things they do and value the things they do. There's huge redistributions of human beings. Flows within America are amazing. Hundreds of thousands of people moving to new environments just to kind of help maximize the consonance of the community that they live in with their personal goals and values. And then it's important to make positive change, throughout society. So there's been a redoubled effort in many people's part to, sort of address issues of social justice, economic justice, the kinds of big picture, sort of questions or challenges that structure the world around us and, sort of kick off or sustain these states of chronic threat. So that's one level of intervention. The next that, comes up, especially in the work that we've been doing together, is, in no small part, in the kind of the Shakespearean rose sense, how you perceive the world around you is a tremendous influence on how your body is going to respond to that world. And there are, sort of different ways of interpreting the very same event that will lead to very different physiological responses. This classic example being, sort of challenge versus threat coping, feeling like I can overcome obstacles and challenges, as opposed to feeling like I can't deal with them and they're going to destroy me, or I need to run away, or something like that. But there's another version of responding to things that is, I think, importantly kind of brought back to the fore of human cultural attention in the last couple of decades. And that is this idea of, sort of, if you will, right sizing our psychological responses to things, not denying threats or uncertainty or challenges, but neither, sort of flying, from 0 to 1,000,000 in terms of our responses to them. So this idea of kind of sizing up the things in front of us without responding in this kind of, for lack of a better term, knee-jerk, histrionic way that, kind of is so easy to do, both through our own upbringing and our desire to stay in control of our lives, which promotes hypervigilance and anxiety, or from the world around us, which is, saturated with media images that, basically very profitably capitalize on sense of fear, threat, and insecurity. That's a great business model. You can sell people a lot of stuff by keeping them, kind of constantly off balance and insecure. So this idea of, what you call the learning of mindfulness, this idea of being able to stop, reflect not only on the world, but on your own perceptions of it and reactions to it, and to let the world be as the world is, and reality check that, in fact, I am not dead yet. And, there probably are ways to get through this. And sometimes actually you don't need to do anything. It's okay to let bad stuff be in many cases. And other times it's really not okay. And that's clarifying as well. So this self-reflection, this awareness, and this ability to deploy tools, not just psychological tools, but, actual physical practice tools, things related to relaxation and, generative activity, being able to redeploy attention and to collect attention. So one of the things that the modern world does is it fractures attention and, it's constantly bombarding us with invitations to look at this, look at that, do this, do that, pay for this, pay for that, worry about this. And that, it's wonderful to be able to recollect all of our attentional resources back to, like, what are the 2 or 3 things I really care about? And, on my deathbed, or, as I go to sleep tonight, even, like, what's going to matter today? And if this is not it, maybe I'll spend my time differently. So these mental practices of, keeping ourselves rooted and anchored in a mode of existence that our hunter-gatherer forebears actually lived in all the time, because they just didn't have Twitter and the internet stressing them out all the time, and trying to get their grants funded and their pitches accepted and all this other kind of stuff. It was basically like, let's go find some food. Yeah, all right, there's some food. I'll work on this part, you work on that part, right? That is a much easier and in many respects more kind of spontaneously sociable way of being than the world we've gotten ourselves to.
And
so that's another intervention point. Let me point out, there are intervention points, if you will, downstream of that. There's sometimes when you just realistically, you can't even ethically ask people not to be stressed about certain things. So a prototypical example is like people get diagnosed with cancer. I mean, you can tell them, hey, this stress, it's not doing you any good. It might even be fueling the growth and metastasis of your cancer. Don't be stressed. But that is just not going to work. I mean, when human beings realize that they are, nose to nose with death, they can't help but be stressed. And it's actually an act of cruelty to tell them not to be stressed, because that's just going to make their disease worse. So in situations like that, we want to be able to take the stress biology off of the table downstream of human psychology. We want cancer patients to be able to do the kind of adaptive coping and the kind of the process of working through the disease that this kind of stress and existential encounter is gonna promote. We don't want people suppressing those kinds of things out of fear. So in scenarios like that, it's a great idea to give people drugs that, for instance, block the transmission of the fight or flight neurotransmitters to the receptors on the immune cells that are going to kick off this pivot in immune cell gene expression. So changing how our physiology works in times when it's not either ethical or maybe even practical to change how our psychology works, that's also on the table.
Those are three good peers to approaching a problem: the larger environment, the person's interaction with the environment using stress reduction, and when all systems have been tackled and are red alerting, we do have prescribed drugs to help with that. And I totally get that. And that can also include, it's not just cancer diagnosis, like death of a very close loved one, and the person has completely lost their ability to function in the world. Sometimes just getting that person to a stability state makes a lot of sense. So thank goodness we have the tools. And as part of meditation, so to talk about that middle ground, you had me thinking that the several elements of what you're doing during meditation might be what's at work here. And I want to get your opinion on it. The first is, maybe in my past, I've relied too heavily on what humans think they are thinking about. So I've given maybe too much credit to psychology. And I'm these days giving a little bit more credit just to behavior itself. So sitting down to meditate, walking in mindful meditation are taking up your time. And you are not doing those other things. Like you're saying, checking your emails, being on Twitter, let's say for that hour a day. And that is probably significant in a lifespan of contribution. So I don't know the buildup. And I think in some of your lectures, I've heard you give a time frame for how the CTRA might respond in stress reduction. I don't know how long it takes, but imagine every day you're removing and counting those hours up. So I would suggest the meditator behaviorally is selecting events in their environment. So that's super helpful, because when I work with people new to meditation, they don't even know that exists. They're like, what are you talking about? Just life happens and I'm anxious and everything's wild. And I'm like, yeah, but with this, you realize you do gain a sense of control. So is it part of this just humans selecting environments? Like it seems to you, what you've said, the environment is very important, but we can select it, right? We can go for a nature walk rather than staying on Twitter.
That's exactly right. And in fact, that's, I think, one of the most powerful impacts that meditation has is this kind of metronomic, almost kind of existential philosophical interlude. So, the existentialist philosophers always remind us that every day you're making choices. Every day you are deciding to go to work at the same place again. Every day you're deciding to keep living life as you're leading it today. And no day do you absolutely, are you absolutely forced to make the decision the same way. We all have far more freedom than we take advantage of, or in many cases than we assume, or in some cases even realize. So what's interesting about the metronomic practice of meditation is that it is a sort of a kind of almost like a physical reminder to pull back from the stream of anxious, obsessive, hypervigilance and all that kind of stuff, and just check, do I still want to be doing this? There's no reason I cannot do something else today. There's no reason I cannot be a different way. There's no reason I could not spend my time a different way. And one of the things we've learned is that these choices, some of them can be very sticky and addictive, and just merely interrupting them is enough for people to just realize, yeah, I don't want to spend my whole day, sort of obsessively checking updates in my news feed. Like, the world will be there tomorrow. I can let that be for now. And there was a huge amount of this, all of our experiences, I think, of the pandemic, or a great reminder of just like, at some point you've just got to let it be, because, there's so much of this stuff that you can't control. B, it's going to be there tomorrow. Whether you learn it now or you learn it tomorrow isn't going to make that much of a difference. And at some point, you can just like overwhelm your brain's capacity to absorb worry, anxiety, uncertainty, threat, that kind of stuff. And that actually doesn't help you. It doesn't leave you in a better place to actually respond to the things that you can control and you do need to sort of effect. So I think this kind of reminder, or this stop, or this interrupt function, is one of its strongest components. One of its least recognized ones is this constant reminder to make choices, and that they matter for you and how you live, and even how your body works and what your genes do.
And to touch on that gap idea, that experiential gap, when you see stimulus everlasting in your environment, especially now, when sitting around the fire, there was no phone and there was no Twitter. Now, I mean, you could be going to sleep and viewing those things. So the environmental opportunity is everywhere. The one point that I'm going to take it back to psychology now, but the perceptual elements of a threat, which is another piece I wanted to ask you about. And this is a funny case. My wife is screaming the other day, there's a huge rat outside. There's a huge rat. Her alarm bells, I mean, I don't know why she's this scared. She's inside of a house. All the windows are closed. The house is safe. But she is just screaming threat, like basically jumping on the bed, even though this rat is gone and outside and probably terrified. Now, I don't even know if it was a rat. Knowing my wife, it was, probably an opossum getting a drink from the fountain. But it's funny, in that moment, there was a immediate pause. And perhaps this has to do with disposition or with practice, I don't know. But a pause, an uncovering of this whole situation, like just in the moment, of just how comedic this is, how wonderful it is. And there's the psychology piece, perhaps, that, you could see threats, and that was just a ridiculous example there, but it could extend, and I know some stressors are so tragic, it is hard to see it in this way. But day in, day out, can we argue that humans can psychologically reframe threats? Because that's what's happening, as you argue, threats in the environment, we see them as stressors, there's a biological cascade. Can we learn to remain non-reactive psychologically so far that there's no biological repercussion? Or can we play with it only in the little? Are we got in the margins on that one?
I think that it's a never-ending struggle. I don't know anybody who's just talked themselves out of reactivity, and all of us need to react at some point, or we're going to get hit by a bus or something like that, right? So,
or bit by that rat, but it wasn't a rat.
Yeah, that's right. So I think the good news is reactivity will never leave us. Normally we're in no danger of actually shutting that down so much that we just fail to pass the reality check of jumping out of the way of the bus. in general, the errors we make are towards, staying engaged with threat or uncertainty or terror because of this trick of the human brain that it is all about solving problems. And so, if it sees a problem, it's like, wait, let me erase that problem. These days, the world around us is great at piping problems our direction, problems that we cannot solve ourselves. And so that, I think, is going to be the challenge all of us face, is, sort of keeping ourselves in the sweet spot of recognizing the challenges that you want to engage, the ones you care about, and engaging with them in a way that's not self-destructive and anxiety-provoking, but basically is generative and change driving, which almost always involves working with other people, coming together in community to make things happen. And that's actually what we found to be the strongest antidote to this kind of stress or threat biology, especially over the long run, is people who are engaged in some kind of cause or purpose greater than their own immediate self-gratification. People that are, trying to raise kids, that are trying to make the world a better place, that are trying to serve communities, even people, trying to keep a business growing and thriving and helping its customers. These are all tremendously engaging kinds of behavior and are great competitors for this constant addiction to, sort of terrifying news and sort of like dramatic social media and things like that. So that kind of psychology is also good at, helping people feel fundamentally okay. It's much harder to dangerously threaten a person, especially for a long period of time, when they are working for the good of humanity or starfish or whales or whatever, people that, are really connected to community and trying to make the world a better place and are pursuing this kind of value judgment. And that kind of psychology, interestingly enough, when you go back to the monks who actually worked up meditation, they thought that the way we meditate is a little bit weird. Like if you talk to, sort of monks these days, they'll be like, yeah, you guys are clearing your minds and reducing your stress, and then you just sit there. Don't you get bored? Which is actually what happens to me when I meditate. And they find out, the reason to meditate, at least the reason we developed meditation in this kind of Buddhist tradition, was mostly to clear our minds so that we had, sort of gathered together all of our attentional and emotional and perceptual resources so that we could ponder moral philosophy, so that we could think about the world as it is, the world we wanted it to be, and how to move towards the life we wanted. So they really, often think of this, this is not uncommon to hear, for instance, the Dalai Lama talk about this in his writings about this, that, sort of meditation becomes, if you will, a foundation for social action, essentially, in some direction toward the material improvement of the world. So that notion of coupling together, of recovering your strength perceptually and emotionally and creatively, and then using that kind of space that's opened up to kind of plan for actually making material change in the world, so that you begin, let's say, the meditative practice in what we would call the seated practice, but then take the consequences of that actually out into the world to change those ecological systems that we talked about earlier as being kind of the major, or one of the major kind of precipitating factors that kick off all this stuff inside us in the first place. Hopefully, we will get to that kind of virtuous circle where the things we do ourselves psychologically then become part of communities and worlds, and essentially, ultimately have a positive health promoting impact on the material environment around us.
And your work has done so well at telling us why, and a good rationale, a biological rationale for why we should be doing this, as each one of us individually as humans. We're protecting ourselves, self-preservation. So let's conclude for today. Thank you so much, Dr. Gull, for all your work, for your inspiration, for giving this awesome model to think about humans, where we are. And mindfulness is just one piece as a practice that might help us reappraise our environments and to perhaps select better environments. Listeners can find our podcasts at goamra.org, goamra.org, where you can also subscribe. That's it for today. Bye now.